In this video, we are going to look at how we can find the amount of air in a given equation. So in roasting, air is used for oxidation of sulfide as well as combustion of coal. So in this case, we need to find the amount of air theoretically needed for the combustion and also for the oxidation of the sulfide, right? So now for this, let's look at the combustion of carbon. So combustion of carbon, right? So we are going to find the amount of air. In this case, we need the amount of what? Oxygen, right? So we are going to use this to generate the formula in which you can use to find the amount of what? Oxygen needed, right? So for combustion of carbon, we know that C plus O2 giving you CO2 gas. Now we know that the molar mass of carbon is 12 and the molar mass of oxygen gas is 32, and this is 44 grams per mole. Now for a complete reaction, right, for a complete combustion, that means that for a complete combustion, 12 kilograms of carbon, yes, will require 32 kilograms of what? Oxygen. So 12 grams of carbon will require 32 kilograms of what? Oxygen. Are you getting it? So for a C kilogram of carbon in the fuel, oxygen required for a complete combustion. So we're finding the oxygen required. The oxygen required. So oxygen required. The formula we're going to use is 32 over 12 times the mass of carbon or the composition of carbon. That is the formula when you are dealing with combustion of carbon. 32 over 12 times the carbon. We'll solve some examples and you understand. Let's do combustion of what? Combustion of hydrogen. For combustion of hydrogen, we know that 2H2 plus oxygen gas giving you 2H2O. So we're finding that we know that we need this will be the molar mass will be 4, this will be 32, and this we have 20 here. So in that case, we're finding the oxygen required for a combustion reaction of hydrogen. It's going to give you the oxygen required formula. The oxygen required will be what? 32 over 4 times the hydrogen kilogram of oxygen. So in the question, they're going to give us the kilogram of hydrogen in the question, and then they will ask us to calculate for the oxygen required. With that, you're just going to have 32 over 4 times the what? The kilogram of what? Hydrogen. And that is how we can solve it, right? Now we have the next one, which is the sulfur. So let's do combustion of sulfur. So with combustion of sulfur, we know that combustion of sulfur, we have so sulfur. For sulfur, we know X plus O2 giving you SO2 gas. So we know that this is the molar mass is 32, this will be 32, and this will be 64. So in that case, we're finding the oxygen required. Oxygen required will be 32 over 32 times the sulfur kilogram, right? Yes, the sulfur kilogram. We want to generate another formula for finding the amount of air, the minimum weight of air. That is what we're doing, right? But what we did now was the weight of oxygen, but not air. Now you know that on combining the three composition or the complete combustion for the formulas, which is for sulfur, hydrogen and carbon, we can now generate how we can find the amount of what? Air. So we are just going to combine the formula, and when you combine the formula, we are going to have a formula which will be 32 over 12 times the composition of carbon. You know that, right? Then plus this has been established, hydrogen is oxygen, right, over 8, then plus what? Sulfur. So we've combined the three formulas that we did for the complete combustion, and when you do that, we have this one. So in the air, amount of air, we have carbon dioxide, we have hydrogen, we have oxygen, we have sulfur, right? Now we're finding the amount of air theoretically. We know that the atmosphere contains 23% of what? Oxygen, and 2% of nitrogen, and the rest is others, right? So air contains 3% of, or by oxygen, right, by weight. And so let's take note of this. With air, right, it contains 23% by weight of what? Oxygen. So by weight of oxygen, and 21% of what? 21 by volume of oxygen. So we have 23% by weight of oxygen and 21% by weight by volume of oxygen. So in that case, we are just going to add do some substitution and find the formula for finding when they ask you to find the amount of air, right? Which formula are you going to use? So for amount of air, we know that for the minimum weight of air, we can establish that 100 over 23 bracket open 32 over 12 times the composition of carbon plus 8 bracket open hydrogen minus oxygen over 8 plus sulfur. So this is the formula for finding the minimum weight of air. The minimum weight of air. The one that we saw was the weight of oxygen. Then, and we combine the weight formula of oxygen together, then we get what? The minimum weight of air. Then, for the minimum volume of air, we are going to get 100 over 21. Then we have 32 over 12 times carbon. Then plus 8 bracket open hydrogen minus oxygen 8 plus what? Sulfur. Right? So in this case, we have expressed it. And now we are not dealing with percentage. So when they give you in percentage, you are going to change it to with the mass, by mass. I get it, because I told you that with the carbon, you need to change it to what? If they give you 100%, you change it to what? 1 kilogram. 82 is 0.82. The same applies to the hydrogen composition and the sulfur composition, right? So now let's take an example and solve that and see how we can go about it, right? Okay. Now, first, we know that this is what? With carbon. So let's write solution. Let's write the combustion, complete combustion of carbon. So carbon plus oxygen giving you carbon dioxide. This is it. And let's check its balance. This is a balance equation. So what we know that this is 12 kilogram. This is 32 kilogram, and this is 44 kilogram. Right, weight. Now we established that for us to find the weight of oxygen for a complete combustion of carbon, what we know is that it will be what? The formula is 32 over 12 times the carbon in what? Kilogram. And in that case, they gave us to be, they said what? Of 2 coke, assuming 100%. That means that for the carbon, the weight of carbon is what? 100%. And by weight is 1 kilogram, right? So when always the weight to be given to you in percentage, if it's not given to you, we assume it to be 82%. That is 0.82. So in that case, for us to find the weight of oxygen required, we are going to have 32 over 12 times 1, which will give you 2.67 kilogram. So this is the what? The weight of oxygen required. But they are asking that a complete combustion of 2 kilogram coke. That means that we are going to multiply this by 2, right? So for us to find, we are going to have 2 by 2.7 kilogram. And in that case, our answer will be 5.33 kilogram. In this case, we are finding the weight of oxygen required, but not the amount of air, right? Okay. Now they ask us to find the what? They calculate the composition of the dry product, right? So for the composition of dry product, we know that the dry product here is carbon dioxide. So carbon dioxide formed, right? And in that case, we can do that. For us to find the dry product by weight, we have to be 44 over 12 times 1, which will give you 3.66 kilogram. And in that case, since it's 2 coke, you're going to multiply it by 2, 3.66 kilogram, and that will give you your answer, right? 2 times 3.66, which will give you 7.32 kilogram. Let's note this very well. Now, this is ratio and proportion, right? If 12 grams will give you 1, what will be 44? So if 12 grams will give you 100%, what will be 44? So then 44 will give you 36.6, right? That's what you are trying to do. So 44 over 12 times the composition, that is times the C in kilogram. And in the C in kilogram is expressed as a percentage. So you need to change it by mass, whereby it will be 1%. If it's 82%, you're going to have 0.82 kilogram, right, of coke, of carbon. Then of coke, yes, it's the same as carbon. Then use it for the calculation, right? Yeah. So that is it. Now, so in any question, they are going to ask you to find the weight of oxygen required. You just need to use this formula. And if it's